Hello students, Ms. Slyman here, and in this set of notes we're going to be looking at exponential functions. So the start of an exponential function is that it's a function written in this form where we have a base b raised to the power x. B has to be greater than 0, so let's think about why that is. If I think about a table of values with this function, then I would have my x. Ooh, look at that. Let's make that. I would have x and I would have f of x values. And if my b value was negative, so let's say for example that b was -2. Well, if x is 0, -2 to the 0 is 1. If x is 1, -2 to the 1 is -2. If x is 2, -2 to the power 2 is 4. If x is a half, then I have the square root of -2, which is imaginary. And if I'm thinking about how I'm going to graph this, it's points that are oscillating between positive and negative and imaginary. So this is not a function because it's not going to be continuous. It's not going to have points that all connect. So the base has to be positive. Furthermore, to be an exponential function, the base can't be 1. And if I think about y equals 1 to the power x, well, that's just 1. That's a horizontal line, not an exponential function. So we're going to have some scenarios, though. I'm going to have a scenario where the b value is greater than 1, and then my exponential function is going to look like this. It shows exponential growth. If my b value is between 0 and 1, and again, those are strict inequalities. I have to be between 0 and 1. Then I've got exponential decay. So this one was exponential growth, and this one is my exponential decay. For each of these curves, I can see that my domain is all real values. So x can be anything. I can have negative exponents, rational, irrational, doesn't matter. And my y values are all going to be positive. I've got a horizontal asymptote here of y equals 0 in both scenarios. So that helps establish my domain as well. The y-intercept, well, anything to the power of 0 is 1. I said horizontal asymptote. And again, we've got this word monotonic. So exponential growth, I've got monotonically increasing. Exponential decay, monotonically decreasing. So constantly growing on this side, constantly decreasing on this side. So that's your introduction to exponential functions.